Scholars, how do we find vertical asymptotes when we are dealing with rational functions? Well, let's see. Um, let's assume that f of x, of course, is a rational function, p of x over q of x in its lowest form. Then x equals c, this vertical line, will be a vertical asymptote. Let's call it a VA for short, of the function f of x if the number c is a real zero of the denominator q of x. Okay, let's do a couple of examples, very similar yet very different. So we see the behavior of each of these rational functions. Just to keep things easier to see, to appreciate, let's find the domain and the vertical asymptotes. Let's try those. First example, x over x minus 9. Notice that the function is in its lowest form. How do we find the domain of any rational function? We must avoid 0 in the denominator. So when my denominator x minus 9 equals 0, x equals 9. Thus, the domain will be all real numbers except when x equals 9. In other words, you get infinity to 9 union 9 to infinity. And the vertical asymptote will be exactly that, x equals 9. Example number 2, x minus 1 over x squared minus 9. Notice that my denominator can be factored as x minus 3, x plus 3, that's your difference of squares. And here the domain, once again, would be what number makes my denominator equals to 0. If this guy equals to 0, x minus 3 equals 0, therefore x equals 3. Or x plus 3 equals 0, therefore x equals negative 3. So I must avoid negative 3 and positive 3. So my domain will be from negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. Since the function is in lowest form, in this case, my two vertical asymptotes, x equals negative 3, x equals 3. Let me add the third example on this one. What if I have f of x equals x minus 3 over x minus 3, well, I mean, x squared minus 9, of course. Let's see how to do this. Okay, so I'm done with this one. Let's go ahead and do x minus 3. That will be easy. Notice that the function is not in its simplest form. I can simplify x minus 3 over x minus 3. So in its simplest form, the function will be 1 over x plus 3. The domain, of course, is the same thing as before. It's the same denominator, x minus 3, x plus 3. So we maintain the same domain. However, in its simplest form, the only number that makes my denominator 0 would be x equals negative 3. Okay. Notice that we lost x equals 3. So at x equals 3, we'll experience a discontinuity. So, or we call it a hole. Joseph, we have to always justify the two exceptions of the domain. Either they become asymptote or discontinuities. What is discontinuity? Reward discontinuity. That's when we actually simplify. So if the graph is not the asymptote, it will be a discontinuity. So look at the difference in the graph here. Okay, that means the discontinuity versus the asymptote. So that will happen. Let me stop sharing. What about this one? Again, the domain, well, when the denominator equals 0, x squared minus 9x equals 0, notice we can always factor out an x. x minus 9 equals 0, zero product. So x equals 0, x minus 9 equals 0, x equals 9. So these are the two bad numbers. Okay, we have to avoid 0, and here it was x equals 9. We add 9. So my domain will be all real numbers except, of course, those two numbers. Domain, so all real numbers except 0 and 9. Okay, I'm putting 0 and 9. However, the vertical asymptotes, let's see what happens. We must factor. So this one factors as x parentheses x minus 9, and here will be x. Notice that indeed x over x simplifies in its lowest form, simplest form. My function is 1 over x minus 9. So once again, this function experiences only one vertical asymptote, even though we have two exceptions in the domain, two restrictions. In this case, x equals 9 will be your VA, vertical asymptote. And at x equals 0, we have a removable discontinuity. Thank you. One last example, what if I have the following function, 3x cubed plus 3x squared minus 90x, 2x cubed minus 4x squared minus 30x. So we have to factor, of course, greatest common factor in the numerator, 3, 3, and x, so it will be 3x, will be x squared plus x minus 30 by 30, that would be 30. Which in turn factors as 3x, factors of negative 30, that gives me plus 6, so negative 5 times 6, that will be x plus 6, x minus 5. So yeah, okay. The denominator, 2, 4, 30, numbers are even, x cubed, x squared, x to the 1, so I can always factor out the 2x, will be x squared, 2x minus 2x minus half of 30, that will be 15. 1, 5 will be 2x. Factors of negative 15, that gives me negative 2. That would be x minus 5, x plus 3. Yeah. Okay. So the domain, of course, we need to avoid 0, 5, and negative 3. I'm going to take an easy way out. So it will be all real numbers except negative 3, 0, and 5. Those are the three numbers. I will make my denominator 0. What about the VA? In theory, we should have 3 of them. Not really, because notice that when I simplify the function, x over x is 1, x minus 5 is 1. So my function in its lowest form will be 3 parentheses x plus 6. And the denominator, we have 2 parentheses x plus 3. So of course, we only have one vertical asymptote, which is x equals negative 3. At x equals 0 and at x equals 5, we'll experience a discontinuity. Thank you.